Hi, it's Graham again from Spectrum Eye Care. Today I will talk to you about the colour vision, colour wheel that we've developed here at Spectrum. The ability to see the world in colour. This is an ability we humans have been blessed with. We take in the beauty and the rich and vibrant colours of a scene or picture, and we take it for granted. But do we all see colours the same? Research shows us that some individuals have colour deficiencies, and there are variations in these deficiencies. At Spectrum, we've developed a quick and easy way of detecting and categorizing these deficiencies. Individuals have just been told, you are colourblind. Firstly, that's not true, and now the individual has no idea why, how, or what the mechanisms responsible for a colour deficiency are all about. Using the Spectrum Colourwheel, you'll be able to identify a total or a partial colour deficiency, as well as being able to identify the receptor cell that is responsible. We talk about opias. Opias mean complete, and we talk about homilies, which mean partial. For example, a deuteranopia would indicate an absence of the green receptor cells, whereas a deuteranomaly would indicate that there is not an absence, but merely a reduction in the sensitivity of the green receptor cells. The colour wheel is only available in Spectrum version 6 or later. We are using version 6 for this demonstration. So let's have a look what it looks like and how the tests are done. Firstly, we select auxiliary from the top toolbar, and then colour from the lower toolbar, and then colour wheel from the sub-menu over here. This brings up the colour wheel. Please note, if you're using two screens, you are able to toggle the colour wheel back and forth between the screens by simply pressing F7 on your keyboard. The patient instructions are displayed in the center of what looks like a clock face, with tabs next to the numbers. The first screen is the control screen, and you'll notice that the tab adjacent to the number 8 is orange, whereas all the other tabs are grey. This is the control screen, and the patient gets an idea of how the test will work and what it will look like. We instruct the patient to notice which colour tab is the odd one out, or which one is a slightly different colour to the others. The screens will only display for 2 seconds. Research has shown that if given too much time, patients are sometimes able to eliminate the odd one out, which will distort the results. By selecting the Start button, this is the first screen. After the first screen is displayed for 2 seconds, the tabs will all turn grey, and the patient would now move the mouse over the tab they chose as the odd one out. You will notice that the tab turns white if you hover the mouse pointer over it. By clicking the left mouse button, the patient can select the tab of choice once it has turned white. If they are not sure, they would want to select the Not Sure button here in the middle. Once they have made a selection, the program will display the next screen. This will continue till the patient has made a selection for all 18 screens, and after which the program will display a result screen. If the patient is overwhelmed initially, let the test run for a few screens first, and then they just get a general idea. Then you can restart it by selecting the Restart on the top menu once they have an idea of how it works. This will give them a brief description of the condition that's detected, and it will also offer a picture showing normal colour vision, as well as a simulation of how the patient would perceive the same picture. From the simulation tabs at the top, one can show the patient or their spouse how an individual with various deficiencies would perceive the picture. There are 7 different scenarios here that can be used to show how colour deficient individuals see colours. There's also a screen which will give a result of inconsistent. This will be displayed if the patient just selects at random, and it offers the opportunity of repeating the test. You will find this a very nice enhancement to your eye exam, and it is something new for your patient, and they would have not seen it before. It creates a nice talking point, and it is interesting to see a spouse's reaction when the result screen is displayed, and the patient reports that the 2 pictures look the same. Many can't believe it, but it gives them a nice appreciation of how the patient perceives these colours. Deuter anomaly is the most common of all the deficiencies, and you are likely to see many with this condition, as most go undetected by the common screening tests. So there you have it. By the way, we at Spectrum are presently engaged in a few research projects. We would welcome your participation and input, and of course we would always be glad to help should you wish to conduct some research of your own. Contact us at feedback@digitaloptometry.com. Please subscribe to our YouTube channel and be sure to check our website for other great tests at spectrumicaresoftware.com. Thanks for watching. More next time.